Alright, welcome back. So in my last video I covered closure syntax, so showing you how to create a closure the long way, and then showing you how to refactor from the long way to the short way. And then I also introduced how Swift infers the type for parameters and returns, so that we have less basically to type. Now this video is a replacement for the other one where I covered shorthand parameter names. Between Swift 2 and Swift 3 there were a lot of changes. Basically sort turned into sorted by, which caused a little bit of confusion and definitely a lot of errors. So that's why I'm redoing this video. But the concepts still apply. So if I don't explain something extremely well, definitely go to the Swift 2 video, where basically I'm explaining exactly the same thing, just showing you the code as it applies to Swift 3. The concepts are the same. It's just the keywords are different. So again, sorted by well, before I said sort, and it was like this. It now equals sorted by for Swift 3. But basically, sort is an array method. What it does is it takes an array, and well, actually, it takes a closure, and that closure will describe how sort is supposed to go through and sort through this array, and then it will return a new array based off of what you wanted to sort it by, or what rules you set for sort to do. Alright, so basically it's a high order function. It's really similar to filter, map, reduce, etc. I will review those ones and see what's different. If I need to do a new video, I'll be doing a new video on that as well. But let's go ahead and get started and go from there. So let's create an array, because that's what sort means. It's an array method, so we need an array to work with. So if we do game scores, so we have a couple of gamers playing a game, and we need to know who won the game, right? So let's go ahead and enter some very random numbers here. You can make them any numbers you want. You don't necessarily have to follow what I'm doing. That person was really awesome, by the way. So yeah, just type in some random numbers here. Let's just do one more. Okay, let's make this look pretty. And some spaces. All right, so we have our array of game scores. Now what we want to do is we want to determine who won, or who was second or third or fourth or last place. So what we're going to do is use sorted. And basically sorted, the function type for sorted is that it takes a function that looks like, or a method, or in this case we're going to be doing closure, that has this format. Basically we want to bring in two integers. We want to compare it, and then this comparison will either return a true or false. And then in the end, what sort will do is we'll take all the ones that pass and then sort them in, or actually create a new array that is an integer. Alright, so let's do the long version of this. Don't know why I have an error message there. Okay, there we go. Got a space. Spaces are important, apparently. Alright, so let's do our long version. So we do function. We want to sort ascending. And now with that, we know that we need our function or our closure to look like this. We need to bring in two integers and then return a Boolean, so a true or false. So let's go ahead and bring in two integers. So we have I int and j int. to represent our two numbers that we're comparing. And then we are going to return Boolean. Okay. Let's go ahead and delete this because Swift doesn't like that. All right, so now we need to return how we want to sort. So we want I greater than J. That will be sort ascending. Okay, so let's go ahead and try out our new closure. So we're going to do another constant. We're actually going to do a constant here because we're not going to make this, we're not going to make any changes. So we do game sorted long, where it equals game scores dot sort ascending, sorted by, and we're going to do our sort ascending closure. All right. And there we go. Our closure worked. It sorted all of our game scores up here from largest to smallest. All right, but you know, that's tons of typing. So let's go ahead and refactor this to a inline closure. So instead of typing out function and then giving it a function name and all that jazz, we're just going to actually just create a completely new constant. So we do game scores sorted in line equals game scores dot sorted by. Now we need to enter in something in here that is in line. So we can basically do without one providing a function name. So let's go ahead and throw that out. So we're going to do our I int, j int, and then instead of doing, oh wait, then we need to return Boolean. But instead of doing curly brackets, we're going to do in. And then what we want it to do is we want oopsie, I forgot my curly brackets here. Curly brackets there, and we need a curly bracket here. And then we need to do return I greater than J. Okay, and we get exactly the same result as above, but this time with less typing. We didn't need to add the function keyword. We didn't need to add a function name. We just chopped all that out and entered this in, basically, without the curly brackets, of course, because the curly brackets are replaced with keyword in. And because we added the in, the curly brackets go outside, so it encapsulates our closure here because it's in line. But we can actually go even further and refactor this again. So let's go ahead and do that using type inference, because here we inferred the type. We said, okay, I is an int and j is an int. We don't actually need to do that. Swift is smart enough to realize if you bring in an array, or if I work on an array, I can infer the type of said array. Because up here, if you notice, I did not set the type of this array. But if I hold down my Option key and I hover over it, I can actually see that this array is an integer, is an array of integers. So because Swift is great at type inference, we can refactor this even more. So let's go ahead and do that. So we do game scores sorted inferred. We do game scores, bring in an array sorted by, and we do our little curly brackets here. And so what I want to do is I want to take out the int part So I'm going to do I, comma J, and I'm also going to take out the Boolean part because it knows that if I'm bringing in two integers or bringing in two parameters, it's always going to return a Boolean. So I'm going to do the in keyword, and then I'm going to do I greater than J. And we should get exactly the same result. Let's go ahead and call this constant and see what it is. All right, it has done exactly the same thing as above. So we can actually refactor this yet again, but this time I'm going to introduce a new concept, and that's actually shorthand argument names. So what basically shorthand argument names are is that Swift actually provides some shorthand argument names to inline closures. So this is an inline closure. This is also an inline closure. It's just inferred inline closure. And so we are able to use shorthand argument names to refer to the values of the closure's arguments that are preset. So these argument names that Swift provides, basically it's a $0. So that would be the first argument. $1 is the second argument. $2 is the third argument, and so on. So again, we can actually refactor this even further, because Swift knows, okay, the sorted function takes into parameters. It's going to return a Boolean and an assorted array. So if you just provided what its return is going to be, it automatically knows, okay, this return means that I'm going to infer this portion. Actually inferred this portion here. All right, so let's go ahead and do that again. Let's create another constant. So game scores sorted. We do short arg for short argument names. Again, we bring in our game scores array. U dot sorted by, and what I'm actually going to do is do some curly brackets. I'm going to do return. So I'm actually taking all this out. So this is not going to be in this one. I'm just saying return. And because I'm not specifying what the parameter names are here, I'm actually going to use the shorthand argument names, which is $0 greater than $1. So first parameter is greater than second parameter. Let's see what that returns. And we should see that it returns a sorted array. Eventually. As it thinks about it. Okay, there we go. So awesome. So there we go. That is shorthand parameter names and shorthand argument names. Alright, so here I'm going to switch over to the previous video because it applies to Swift 3. Capturing values. Closures can capture constants and variables from basically the surrounding context in which it's defined. So it can refer to and modify the values of whatever constant or variable is there from within its body, even if the original scope has that originally defined them doesn't exist anymore. Okay, so I'll show you a little example of a closure in a global context, but it's It's not meant to be something you should use because it's obviously not helpful. It doesn't really utilize what closures are meant to do when they deal with values. But it's to give you an idea or kind of show you that what a closure can actually do. So let's just jump in. So global. Global meaning anything can see what is there. So if I just, type out a variable and just name it a number, let's say that number equals 2, anything that sees this variable, actually everything will see this variable is what I should say. So it doesn't matter if it's above or below, it will see this variable. That's what I mean by global. I mean, you can do work on a global variable. For example, if I did var multiply by 2 and have that do some work on the number. So do times equals 2. So when I utilize this, this will actually do work, multiply by, this closure will do work on number 2. Okay, so if I type out this number int, we'll see that it does equal 2. Now if I call my closure, and then call a number again, you'll see that it equals 4. So it's doing work. The thing is I can call anything. I can do another closure, say add 5. Okay. Because I'm calling a number, it will change the value of a number. So if I call add 5, it will now change the value of a number. If I do a number again, as you see, it equals 9 now. So that's what I mean by a global sense. I mean, anything can have access to it. I mean, here's two closures that are doing work on a number. Now the thing is, and that's one of the things that makes closures really useful, is that they can capture values. So, and they can capture it in 2 places and be completely separate. So internal. So internal meaning not in a global context. So basically anything that's inside a closure or a function, it can track the internal information encapsulated by that variable as defined in their enclosing scope. So they basically reference the closure. And the simplest way to do this is to basically use a nested function. So I'm going to create a function here. Oops. I'm going to do that. Sorry about that. So back to where I was. So let's create a function. I'm going to create a function that will deduct by, it'll take in a number and deduct it by whatever number that you put in. So say if I put in 5, and then it will, if you say deduct by 2, it will accept 2 as what it's going to be subtracting the start by, or the number that we first set it to. This makes sense in a moment. So I'm going to call this make deduction. And so I'm going to have it bring in 2 parameters. One is our start number, and then the second one is our step. So we're going to bring one number in that will be the number that we will be subtracting from, and the step is the number that we will be, actually no, the start will be the number where we start at. So say if it's 10, and step is the number that we're subtracting 10 from. So if it's say by 2, that's what we bring into. or -2. All right, and then we are going to call a closure that will output an integer. Okay, so here are our parameters right here, and then our closure has this format. So no parameters, but outputs an int. All right, so I'm going to create a variable here that I can use to do work, and I'm going to set it to my start number. And now I'm going to create a function inside, so this is where the nested function part comes in. I'm going to create another function inside that's actually going to do some of the work, actually all the work. So I'm going to call this Tractor. And it has to have the same format that we specified up here. So no parameters and return an integer. And now we're going to give it some functionality. So the thing I want to really point out here is that the function subtractor, I know it has this really interesting syntax right now, but the thing is that function subtractor has access to everything that's coming in to make deduction. So it has access to this variable and this, as well as the variable that we've defined inside the function. Okay, so with that being said, I can actually use everything that's coming in inside of the nested function. So I have total, and what I'm going to do is I'm going to subtract it by the step. So whatever number is brought in, that is going to be subtracted by. And then because function subtractor needs to return something, we're going to actually return total, so that we satisfy this requirement here. All right, but we're not finished yet, because we're actually missing a return with these set of parameters in return. So what are we going to do? Well, we're going to actually return the function subtractor minus the parentheses signs. Okay, so yeah, it looks really odd. Like if you just look at function subtractor all by itself, just imagine that nothing is surrounding it. It just looks like it's unfinished, like it's missing something, but it's not, because function subtractor sees everything that make deduction function has. So it sees all its parameters, start and step. It sees the variable total because it's inside. So it sees everything, has access to everything. The thing is you can't access subtractor from outside of make deduction. And I can totally show you that. So say we're going to have a variable, and this variable is just going to be some random number. We're going to have that equal, let's say 100. All right, so if we try to do some work using subtractor, you can't. Like if I try to do some number, I'm going to try to pull in subtractor, it's not going to do anything, because you can't access it at all because it's in there, basically. But I'll try. I'll try, but I don't think I can do anything. So yeah, see, and there's no member subtractor. Let's see if I can do something different, like let's do var decreasing, and let's assign that to the make deduction function that I had before. And if I do my deduction, I'm going to start from 10, and I want it to subtract by 2 every time it's called. All right. So say if I try, because decreasing is now knows that it's a closure of make deduction, maybe we can now bring in subtractor. I know this isn't going to work because it's not within the scope. It's not global. So yeah, see, it says not used as a property, blah, blah, blah. So I just wanted to show you that you can't access it. You can't access a nested function at all. But the functionality is there. You just can't do anything with it. All right, so now that I made that point, let's move on. So I've created a variable decreasing that references the closure make deduction, or the function make deduction. So now that when I call decreasing, what it should do is it should decrease the number that we start with, 10, by 2. And that's exactly what happened. It's now 8, right? And if I do it again, it's going to subtract by 2 again. And then this time it should be 6, which is absolutely correct. Now the thing is now if I want to add this to my random number, I can just do decreasing with my parentheses. And now some random number will be subtracted by well, actually it's added, which is right. So the value of decreasing, which now would be 4, is now added to some random number, which makes it 104. Now what I can do is I can do something, I could do another variable. So I'm going to create another variable. So I'm just call this decreasing again, because I just can't think of a better name right now. And I'm also going to assign it to make deduction. And I'm going to start at 1, and I'm going to have it step through by 2. Now, you would think that, well, we've already used make deduction up here. Are you copying that into this one? No, I'm not. Not at all. Basically, this is another variable that's looking at exactly the same function, but because closures capture values, what happens in this variable is not going to affect anything in this variable. So they're basically completely separate, but they look at the exact same closure. So again, if I do decreasing again, and that should equal -1, because 2 minus 1 is -1. If I do it again, it's -3. And so now say if I add that to my random number, and now it should subtract. Yeah, so as you see, that's how closures kind of capture numbers. And what happens in one variable here does not happen or affect anything that happens here, because they're both defined within their enclosing scope, and they don't share a scope at all. They don't share the information that they have, but they do reference and do exactly the same functionality because they have made a reference to make deduction. Okay, so I'll show you another example just for kicks and something just a little different, because that was really extremely generic. Alright, so I used to work in a lab, so I'm going to base my next example off of that. So in the lab, I used to track cell counts. So cells that grew in flask A and another set of cells that grew in flask B, and I used to actually do counts. Now it's actually quite manual, so we won't do anything like that, but the functionality is kind of the same. Cells, they multiply, they reproduce, right? Or they split, what have you. So I'm going to create a function that will account for cell division, okay? So I'm just going to call it increase cell count. I'm actually going to call this another example. Okay, so what this function is going to do is going to take a count that you've input, and because two different colonies of cells, two different types of cells grow at different rates, we're going to be able to input the last count and then have our function actually add more cells to that count. Alright, so my first thing I want to bring in is, of course, an integer, because you can't have a partial cell, that doesn't work, you have to have full cells. So int, and what this function is going to do is going to output a closure, so no parameter, but yet it will output an int. Do our curly brackets. Okay, so I'm going to create a variable in here to help me with the calculation. So I'm going to do var total count equals 0. And now I'm going to create my nested function. So I'm going to do function, I'll do growth tracker. And now remember above, we have to make our nested function have these sets of parameters and returns. Parameters, there are none. We're going to have one return, which is an integer. Do our curly brackets. Okay, so now what I want to do is I want to assign total count with the number coming in. So I'm going to do start count, and now I want it to return to satisfy the return that we stated here. So I want it to return total count, which is an integer. Alright, now we also have to satisfy the return for our increased cell count, which is the closure. So I'm going to do return growth tracker. Okay. Oh, minus the parentheses. Don't forget that. You've seen, Swift got kind of angry about that. Alright, so I'm going to have some cell colonies. So my first colony is going to have a count of 103, or 503, okay? And I'm going to now set my variable, or my constant, for these particular cells. And I'm going to say that they grow by 100. So they, when they do their cell division, they multiply, they usually pop out 100 new cells a day, okay? Bear with me. So I'm going to assign it to my increased cell count, and we'll put it in 100. Alright, so we see let grow by 100. If we hold down the option key and roll over it, you see it is now a closure. Okay. So when we call grow by 100, what should happen here? It adds 100 to it. Let's say another day passes by, and now it should be 200. And sure enough, it is. Now, say if I have another set of colonies or another set of cells, totally different from this type of cell that I was working with prior. And this colony has a population of 123 cells. but it goes by a different growth rate. So I'm going to say this colony grows by 20 cells a day. Okay? Same thing, I'm going to use increased cell count, but I'm going to change it to 20. So if I do grow by 20, now it's 20. If I do it again, it should be 40. Okay, so you see it, both of these constants here refer to exactly the same function, or closure, I should say. But you notice their count is totally different. Like grow by 20 didn't even care that grow by 100 was, right there, right next to it. All right, so now I'm going to go ahead and add my colonies to my totals, my running totals to my colonies. And since it's been on the third day, we're going to add another 20. Oops. What did I do wrong? Oh, I misspelled again. Alright, so that should be, 183. If I do the same thing here, and then plus equals, and then add grow by 100, so now it's 300 cells, should be 803. Right, so there we go. It's pretty awesome. Now I know I mentioned quite a bit about closures being reference types. So closures can be and are reference types. And what that means is that when you set a constant or variable to point to a function, it doesn't create a copy. So it actually references that closure. So if the function is called by another variable or constant, it leads to a change in scope. So what I was saying by grow by 20 doesn't even know anything about grow by 100 because it's outside of its scope. Okay? So let me go ahead and show you an example. Another smaller example, a little bit simpler. So say if I have a variable double, and this has an int, and it outputs an int. And then we do our curly brackets, x in, and return 2 times x. Okay. Don't forget our curly brackets. Alright, so now if we call double 2, and it should equal 4, which is absolutely true. Okay, and now let's see, we have another variable here. Do also double. And have that equal double. Now, what do you think this would do? You would think that, well, I'm making also double, I'm assigning double, which is a closure, to this new variable, also double, that these two would have the same value now that double is 4. Let's see if that's right. So if we call also a double and input, let's say a random number of 4, what do you think it's going to be? Do you think it's going to be 16 or 8? It's going to be 8. Why is that? Well, the thing is yes, the variable also double does equal double, but if you remember, double is a closure. It's not a value. It's not a value type. So it doesn't create copies, it creates references. And because also double is outside the scope of double, it doesn't know anything that's going on with the prior double up here. It has no idea. It could care less. It only copied the functionality. It not only copied, it referenced the functionality. Okay? Alright, so I hope you liked my review of shorthand parameter names, which I covered up here, and refactoring that with my wonderful example using short. Kind of exploring how closures capture values and how closures are reference types. So in my next video, I will be touching on trailing closures, which flows really nicely into working with higher order functions such as sorted, map, and reduce. So if you've liked this video or if it's helped you at all, please give it a thumbs up. If you want to be notified when I upload a video, please subscribe. Till next time, my friends, code on.